did, right? Naming, yes? Now we're gonna do reverse. We're gonna do writing the formulas for the stock system. You're given these guys right here, you're given these names right here, we're gonna get the formulas. Now the funny thing is, the nice thing is, we're still using what? The crisscross method, okay? And the only thing you need to know, guys, is your correct Roman numerals. That's basically it, all right? Because table E tells you the names of the polyatomic ions. You know how to use the periodic table in relation to modifying your names for your negative ions, you're good to go. All right, so you're given this guy right here, titanium, right? Roman numeral 2, acetate. And I always tell my students, anything ending in ate or ite, bam, jump straight to table E, it's gonna be there. All right, so titanium, right, just so happens to be Ti, right? Now that 2 right there is always, guys, for the metal ion, always for the first guy. So remember that, make a note of that. So we're gonna put +2 there. That represents the oxidation state that the positive ion is in, all right? No problem, so put +2. Now acetate is on your table E. It comes in 2 different forms, choose only one of them, okay? I like to use the C2H3O2- form, okay? So it's a -1 polyatomic ion. You switch the numbers only. So the Ti is gonna get a 1, which we don't show, and the polyatomic ion, C2H3O2, that's gonna get the 2. Remember the rule, right? Anytime you're placing a number that's greater than 1 by a polyatomic ion subscript, you gotta put a parentheses around it, right? So it's gonna be Ti, parentheses, C2H3O2, parentheses 2, and you're done. Okay, next one. Cobalt 3 chromate. You write CO down, that's cobalt. H or ite, look on table E. Now chromate just so happens to be what? CrO4, right? The 2- charge. So cobalt is +3. How do I know? Because of Roman numeral 3, right? Okay, so don't mess that up. So we're gonna crisscross now. The cobalt gets the 2 from the chromate, bam. All right, let's do that, let's write it in, bam. Okay, the 3 is going to the chromate, CrO4. Remember, if it's greater than 1, the polyatomic ion gets a parentheses around it. So CrO4, parentheses 3, okay, and you're done. So CO2, cobalt, parentheses CrO4, 3. Notice nothing changed about the polyatomic ion. It's still CrO4. It just gets a parentheses around it. All right, next one. So this guy right here. This next one is lead 4 sulfate. All right, lead is Pb. Roman numeral 4 translates to +4. All right. H or ite, table E. See, sulfate is going to be SO4 -2, right? Now, where does this 4 go? To the sulfate side. Where does this 2 go? To the lead side, all right? Subscripts, folks, subscripts, all right? To the subscript. So, what do I write? PB2, parentheses, SO4, parentheses, 4. Now, do I say yay and just walk away? No, I don't. This is a 2, that's a 4. What can I do to them? I can reduce them, people, all right? So we gotta be careful. So this 2 and that 4 reduces, right? So the final answer will be what? PB, right? This 2 reduces to 1. We don't show 1s. SO4, parentheses 2. Okay, so be careful with that. Simplify, make sure that we simplify. All right, bam. Next one. Vanadium 5 nitride. All right? So vanadium just so happens to be V, right? Looking for our table. Nitride, monoatomic nitrogen, negative ion, right? No problem. So nitrogen, you're gonna put N right there. Now I know this vanadium, right, has a +5 V +5 oxidation state, right? The nitrogen, top number, -3, right? Bam. The 5 goes to the N subscript. The 3 goes to the V. Bam. So what my final answer going to be? V3N5. Bam. And you're done. Next one. Chromium 3 sulfide, right? Chromium, once again, if you're not familiar with the names of the element symbols. Don't panic. Find the atomic number from the periodic table. Go to table S. You'll find the names there. You're good to go. All right. So chromium is Cr. 3, Roman numeral, translates to +3. All right. Bam. Okay. Sulfide, monatomic negative ion, sulfur. All right. So S. You look at the top number, right, in the on your periodic table. -2. Okay. Crisscross, right? So the 2 goes to the Cr, the 3 goes to the S. You wind up with what? Cr, all right? 2 goes there, 2 subscript, all right? 3 goes to the S, S3, and you're done, okay? That's the answer right there. Cr2, S3, bam. Last one, guys, okay? If you notice, right, once you're able to name stock system, getting the formulas, right, is very, very, very easy, because the Roman numeral represents a charge for the first guy, always, right? And you just do a crisscross from there. It's a polyatomic ion, look on table E. It's a regular monatomic ion negative. Look on your periodic table, and the charge is there, top number for you. All right, so nickel is Ni, is winding down, bam. Roman numeral 3, right? +3, okay? H or I ending, table E, phosphate. PO4, -3. In your minds, what are you thinking? You got a +3, you got a -3. What are you saying to yourself? Okay? Hopefully you're saying, right, those guys should be able to do what? Cancel each other out. The 3 from the phosphate goes to the nickel. So that's Ni3, right? The 3 from the nickel goes to the phosphate. Parentheses, PO4, parentheses 3, right? Okay? Now what happens? This 3 and this 3, you can simplify them to 1s, okay? What happens next? Your final answer is going to be, try to get some space here, NiPO4, okay? Bam. All right, you guys see that? That's it, and you're done. All right, guys. As always, hard work, the sacrifice equals success. Writing the formulas is very, very easy. Just follow some very, very simple steps. The Roman numeral is always for the metal ion. Okay? You don't mix and match. Okay? If you see a 3 there, that means +3. If you see a 5 there, that's +5. Don't put what you think it should be. Don't look on the table and guess which one it is. Okay? In terms of multiple oxidation states, it's there explicitly for you, all right? If it ends with H or I ending, it's gonna be on table E, okay? Otherwise, you know, the simple as we did before in binary naming and writing and ternary naming and writing, you follow those rules, crisscross method still applies, and reduce where possible, okay? All right, guys, take care.